Hello my dear students, this is Akash SD and welcome to the SD physics classes. I hope so you are doing really great. So students, in this video we are going to solve the question from the chapter atoms, and this one will be belongs to the spectrum of the hydrogen atom. And here we are talking about a single atom. And in which model we have seen about the study of the single atom? Yes, guess please. Yes, Niels Bohr's model from the chapter atoms. So students, here I have drawn the different energy levels of the atom in which single electron is there. Now, hydrogen is there, but others also there, like we can tell He plus is there, Li plus 2 is there. So in all this situation, this model, that means Niels Bohr model, will be applicable. Okay students, so let's start the question. The question is JEE 2024 question. If Rydberg's constant is capital R, the longest wavelength of radiation in Paschen series will be how much? Alpha by 7R. Then what is the value of alpha? So students, as I have told you, this is the different energy levels. What I am telling, energy levels, not energy band, energy levels, a single line. So here you can see very well, when n equal to 1, energy how much? Minus 13.6 electron volt. How it will come? The formula is this one, En equal to, remember that please, minus 13.6 Z square by N square electron volt. For hydrogen atom, Z equal to 1, He plus, Z equal to 2, and Li plus 2, Z equal to 3. Okay. But here I have written for the hydrogen atom. So when N equal to 1, minus 13.6 electron volt, N equal to 2, minus 3.4 electron volt, N equal to 3, minus 1.51 electron volt, N equal to 4, minus 0.85 electron volt, and after that also we can calculate. But most of the time we used to need only this much only. But why we have done this much? Because we have to understand this question very well. So what happened, that is students, this is called ground state. N equal to 1 is called which state? Ground state here. N equal to 2, first excited state, N equal to 3, second excited state, like that it will keep on continue till infinity. Okay, and remember that at N equal to 1, energy of the electron inside the atom is what? Minimum, minus 13.6, and when it will go N equal to infinity, then it will be 0, and that will be the maximum energy here. Okay student, so what happens that whenever any electron is there, in a ground state and it is getting the energy, by the photon, then what happens that electron from the ground state goes to the excited state depending upon the energy what it got. Then when it is going to the excited state, then this is called which spectrum? In this situation, one spectrum will appear, that is called the absorption spectrum. What I am telling? Absorption spectrum. But when the electron will go to the higher energy state, then there it will stay for 10 to the power minus 8 seconds, and when it will come back, that time only which spectrum will come? That time only emission spectrum will come. Okay, and this question belongs to the emission spectrum here. Okay, so I am just telling you here, for example, let's take for example here this one, I am just telling for the normal example, absorption spectrum. Which spectrum? Absorption spectrum. And always how many spectrum lines will be there? A single spectrum line will be there. Okay, now students, if we talk about here the Lyman series, in Lyman series what will happen that here in the emission spectrum, electron will jump from higher energy state to N equal to 1, Balmer higher energy state to N equal to 2, and in this question what they are telling here? Paschen. In this Paschen, what will happen? Electron will jump from higher energy state to N equal to 3. Okay students, so here N equal to 1 is there, 2 is there, 3 is there, 4 is there. Okay, let's take for example here some N equal to 5 also there, and here let's take for example this is N equal to infinity. This dotted line is what? N equal to infinity. So remember that here students, what will happen that here in this situation, when for the Paschen series what will come here? What will come here, as what I have told you, for the Paschen series it will come N equal to 3. So what will happen that here when the electron will jump from here N equal to 4 to N equal to 3, that time what will be there? This energy difference will be minimum, because see the formula delta E equal to H nu. Okay, so what is there? When adjacent levels are there, for adjacent levels what will be there? This delta E will be minimum. So from here what we can tell? This nu will be also minimum. Okay, and what about the wavelength and lambda? lambda will be what? Maximum. From which formula? This one here, hc by lambda here. So what I have told you, whenever the adjacent levels are there, energy will be minimum, energy difference will be minimum, so frequency will be also minimum and wavelength will be also maximum. That they have asked in this question. Okay, now students, so we can see very well in the question they ask the maximum wavelength. That means the electron will jump from where to where? From n equal to 4 to n equal to 3 in a Paschen series here. Okay, similarly other basics also they are here. Let's take for example, students, if I talk about here electron is jumping from infinity to 3, then that time what will happen? The wavelength will be minimum. Again I am telling here, infinity to 3, then what will be there? This frequency will be maximum and this wavelength will be minimum. Remember that very well. Again listen very properly because concept is important. If I talk about here maximum wavelength, which wavelength? Maximum wavelength always which orbit? Adjacent orbit. That means Lyman means 2 to 1, Balmer means 3 to 2, Paschen means 4 to 3, like this. If I talk about here students minimum wavelength or maximum frequency, so Lyman means infinity to 1, Balmer means infinity to 2, Paschen means infinity to 3. Okay, now the concept is very clear. Now students, we can solve this question a very easy way. Okay, so remember that here students, we know that what is the formula? 1 by lambda equal to, this is the formula, remember that here, Rz square 1 by n1 square and 1 by n2 square is there. Okay, and we are solving for the hydrogen because in the question nothing is mentioned. That means we can write here 1 by lambda equal to r, z value is anyhow 1 square. So here students, again I am telling here, this is called which level? N2 level. This is called which level? N1 level for the maximum wavelength here. So students, what will happen that here, if I talk about here N1, that means it will become here 3 square minus 1 by 4 square here. That means r, and here what this will become here? 1 by 9 minus 1 by 16. Again r, we have to take the LCM. So 16 into 9, 144. And here it will become here 16 minus 9 here. Okay students. Now after that, if I am simplifying this here, no, just simplify this. So what we can tell you, let me write here. So lambda equal to what this will come here? 144 by 7r. Okay. And this one, if we compare with this one, what is the value of alpha students? This value of alpha will be how much here? 144.